In this video, we're going to be answering the following question. Do the following probabilities make sense? We have the probability of A is equal to 0.6, the probability of B is equal to 0.2, the probability of A or B is equal to 0.5. Now, we have the following equation to make use of to help us answer this question. So we have probability of A union B is equal to the probability of A plus the probability of B, subtract the probability of A intersection B. Okay, so rearranging this equation, we get the following. Probability of A intersect B equals the probability of A plus the probability of B, subtract the probability of A union B. Putting in the information we were given, we have 0.6 plus 0.2, subtract 0.5 to give us 0.3. So now that we have this piece of information, we can construct some pictures to explain why this doesn't make sense. Okay, so we have a couple situations to deal with here. So we can draw the following situation. So let's say we have A over here and B over here. And the probability of A, 0.6, probability of B, 0.2. Now this probability of A intersection B is 0.3, and that probability is represented right in the center there of 0.3. Now this doesn't make sense because the intersection of two probabilities has to be at least as small as the smallest probability. And here it shows that the intersection between the two probabilities is greater than the smallest probability of 0.2. So this doesn't make sense in this picture. Now, to show you why it has to be at least 0.2, I can draw a different picture of this of a potential scenario here. So if we draw the second one over here, and let's say we have B here, and then we have A out here. So in this situation, B is entirely enclosed in A. So in this situation, the probability of A is still this entire circle, which is 0.6, and B is on the inside here, still 0.2. So the intersection is the area in which they both overlap, and they both overlap at 0.2. So that's why the intersection can't be greater than 0.2, because the intersection has to be at least as small as the smallest probability. Now, taking a look at the information we've been given, we could have come to the conclusion that the probabilities don't make sense a lot earlier by looking at this in a different way. So we just finished figuring out that the probabilities don't make sense by looking at the intersection. But could we have figured out the probabilities don't make sense looking at the union? So let's try doing that scenario. Okay, so I'm just going to move everything up here a little bit. Okay, so now let's draw one more picture here. Okay, so let's suppose that the two events were entirely independent. Okay, so we have our A there, and we have our B there. Okay, and just move it up a little bit more here. Okay. Okay. So now again, this is 0.6, and this is 0.2. So this is in a situation in which there is no intersection. Okay. So in this situation, okay, so again, this is A, and this is B. Okay. Now I'm just gonna move everything up a little bit more. Okay. So in this situation down here, we have that the probability of A union with the probability of B is equal to the probability of A plus the probability of B. And they are independent, so there is no intersection. So the total probability is 0.6 plus 0.2, which equals 0.8. So that's the maximum amount of probability that can happen when two events are independent. Now, if you look at this situation over here, in that situation, B is entirely held within A. So in that situation, the probability of A union B is simply the probability of A, which is 0.6. And this is because the probability of the union of two events has to be at least as large as the largest individual probability.